Thank you very much. Thank you all for coming. I'm deeply honored by this award because it really comes from the faculty and staff here, and that's unlike me. But as you'll see, I'm not really distinguished, and you may have already caught a little bit of that already. But I'm going to have a little bit of fun today. First, thanking my 200 co-authors in the last, here they're going to zip by. There they go. Hope you see yourself on the list. I've done nothing myself, and so I've required a great deal of help from a lot of other people. They say scientific publications are the currency of our business. These people help me print the money. Keep going. Almost done. So it's a team effort, and it always has been for me, and it's part of the fun, really, of doing work. So today I'm going to give you just a smidgen more of a biography, because I know that Dan filled you in on some of the most important details. Then I'll give you my take on conservation and triage in conservation. And I'll learn how invasive species and climate change research may guide us in conservation. And then I'll take a glimpse into the next frontier, ecological forecasting. I want to see it on the 9 o'clock news, just like everything else. A weather forecast, oh, here's your ecological forecast. And I'm hoping that the next generation, the future, the next generation of scientists can help us with these very difficult tasks. And then I'll give you a little prescription of the future, remembering, of course, that I'm usually wrong. So yes, Dan pointed out that I started off as one of 5 kids. And unfortunately, for disciplinary purposes, they sent all of us to Catholic school. It didn't take, and so I went into science. And I did meet Cindy on December 15th, 1971, almost 42 years ago, the day of one true love, at least for me. She says the jury's still out, going the other direction. Went to Laney Junior College, LU, what we called it, and the first thing I did very poorly in high school, 1.8 GPA, something like that. I was voted most likely to take a life and marry outside my species. The first thing I did, though, I took speech classes, creative writing classes, and literature classes. And those 3 have carried me through the rest of my life, so I highly recommend them. Went to Berkeley, played in Sequoia National Park for 10 years. I studied simple things, easy to catch, plants that would not bite you. Cindy studied bears, relocating them with tranquilizers out of campgrounds and things that do bite you. These are my brothers. I thought I should show them. Again, I didn't get the memo. I'm the only one in the photograph without a mustache. The 5 boys are like the Marx Brothers, and so I used to practice talks, scientific talks for them. I'm the only one that went to college. They would throw beer cans and popcorn at me while I was speaking. So from then on, audiences were rather benign. So in Sequoia, I had a lot of fun. I was involved with a lot of studies on population dynamics of plants, invasive plants, chaparral, native species, the giant sequoias, acid rain studies, and I would spend all summer long on a series of 10-day backpack trips. Boy, did I have fun covering thousands of miles, all your food on your back. It was really a lot of fun, and that's where I learned how to wear Hawaiian shirts. No one really expects them back there. They said goodbye to us, and I went on to UC Davis, where they are famous for pepper spray. When I got to Colorado, I met some very important professors that would change my life once again, Jim Detling and Dan Binkley. It was like being surrounded by smart people. Even though there was like 2 of them, it was like bookends. And it was really fun. And then I started hosting Christmas parties, and I had a really good time with that at NREL. We've had great leadership. Coached Little League for almost 20 years. I won a $10,000 writing contest nominating Cindy as the Mom of the Year. $10,000, 100 words or less essay. Please take creative writing. Moved into the house in Colorado, but if we're not there, we're next door because the Fishers are a lot better cooks than we are. And so there we are. And then I like to host parties. Very recently, I got to walk my daughter down the coconut aisle as she got married. Now, how fun is that? There's Stephen, my new son-in-law, next to me. Shannon, a third-year med student. Cindy and Connor and Michael, who are both mountain men. Connor now in Lake Tahoe, California, and Michael in Gunnison, Colorado. We like to vacation with the Detlings in Cabo San Lucas. These are the boys that are on the loose. Michael turns 21 next month. Watch out. I like to write books in the off-season and late at night, and that's how I want to grow old. All right, now, we'll get to the science part of the talk. My take on conservation and triage. And this is where I want to go for the next 10 years. I want to devote myself to saving the world. Of course, I say I do that now. Every day when I leave the house, I'm off to save the world. And when I come home, I scream open the door and say, I saved the world today. But not really. There's always more work to do. Here are the basics in conservation. It's the wise use of natural resources, protecting native species, and leaving the world as a better place for future generations. How hard could it be? And we have a series of natural areas and a patchwork of natural area, a mosaic of natural areas run by different organizations, but the general concepts are about the same, with some differences. Saving the native species, that collection of native species, seems so very hard for us to do as a species. And that's because we have multiple threats. It's not just one. Human population growth and demand for resources is driving a lot of extinctions. Land use change is driving the next big major chunk of them. Direct habitat loss. Third on the list are harmful invasive diseases, pathogens, animals, and plants. Further down the list is climate change. There are some polar bears and pika and maybe some fish that are in the way of certain climate changes predicted in the future. And of course we have contaminants. We have DDT, which we're recovering from slightly, acid rain, oil spills, and many other contaminants. And there's many more that I could have added on the list. Some of the other threats include volcanism. We've had kind of a slow millennia in volcanism, but it could pick up. We have always the threat of nuclear disaster, because we're idiots. And there are other environmental threats that are waiting, asteroids and other things that are just much further down on the list. So I think we ought to take a triage approach. With these multiple stressors, maybe it would be wise to do what ambulance drivers do. They determine a priority need and then a priority and place of treatment. I think that's smart. Sorting and prioritizing the non-emergency patients, you'll get to those later. They're on the list, but you'll have to get to them later. You got other things more important. And I think that's what we need to do in conservation, to determine the priority native species and critical habitats, and then treat the proximate causes of that decline. The proximate causes, not secondary, not tertiary, not further down on the list, but the proximate causes, where feasible. More things are feasible if you have more money. The threats may differ in different national parks. In Gatlinburg, Great Rocky Mountains, you might have human population growth and land use change right around the borders. You might have harmful invasive species in the Everglades, like those 17-foot-long pythons. You might have climate change, might be very important to Assateague, where just a little bit of sea level rise could wipe it out. And there are contaminants in other parks with oil spills and with air pollution, like in Sequoia and Kings Canyon National Parks, where the air is often as bad as it is in LA. How do you rank these? Which ones do you do first? Let me give you my biases so you know straight off the bat where I'm coming from. Because if you know a person's biases, you can filter out that side of the talk. And here's my bias about climate change. And then why trade and transportation may be slightly an overriding concern for me personally. This is it. 170 million years ago, our continents were all together. They drifted apart with plate tectonics. Then over a million years, we've had ice age and warming periods, ice age and warming periods. The plants that you see today and the animals you see today have seen the ice ages and the warming periods, and they've responded, for the most part. Over the past 12,000 years, we had a little ice age. We had periods that were warmer than today in the Holocene maximum, and we had rates of change that were faster than today. We went screaming out of the ice age. Does this first part, that first part of the graph. That has me concerned a little bit. But in the past 80 years, look what's happened. We have a hockey stick with climate. It is moving up. I'm not denying that it's not happening. But trade and transportation has gone up 40-fold. What we've done in 80 years is we've put all the continents back together again. Something that took 170 million years to put apart, we put them all back together in just 80 years. That has me more concerned than anything else in the world right now. So my bias is that invasive species are the #1 environmental threat of the 21st century, bar none. Did I say that out loud? Bar none. Bar none. They cause our country $120 billion a year in damages or lost productivity. That's more than all natural disasters combined: hurricanes, earthquakes, storms, wildfires, you name it, combined. They have huge environmental costs with species on the threatened and endangered species list. And we have a high cost to human health with West Nile virus, plague, malaria, other things moving up, cholera, on the way, dengue fever. So this has it's come to the top of my personal list. I just wanted you to know that, so you know it's clear when you hear the rest of the talk. Now, conservation issues may change over time. I envision these Indians in the early 1600s talking about what's important here. Well, we might have a little ice age coming. If we only had a good forecasting model, we'd be able to pick that up. But if they watched the sea level rise, they would have picked off, oh yes, these Europeans coming in boats, and they're bringing rats and pigs and horses and cows and chickens and many other species with them. And along with that are the hitchhikers, the diseases, the hepatitis, the smallpox, the measles, the plague, the flu, and many others. So almost 95% of their population was going to get wiped out in a pretty short period of time. What was the proximate cause? We look at conservation in Colorado, and this is 1890. Miners are thinking, well, we're going to bring in stock. We're going to bring in cattle and sheep. We better get rid of some of those predators. That happened big time. They also cleared the forest. We did start establishing national parks around this time, which was a good thing. But there's a legacy of the management of years past, of decades past, of centuries past. And so we have an even age class over lots of Colorado now, where it was denuded at the turn of the 1800s to the 1900s. And we still don't have those predators back, do we? Not really, not the wolves. Last wolf in Colorado was killed in about 1940, the last grizzly bear in 1979. Most of us were alive when the last grizzly bear was killed in Colorado. We let it go on our watch. I'm ashamed of that. In fact, all over the West, if you looked at the rare predators that are out there, the grizzly bear, the gray wolf, and the bighorn sheep, they have something in common. We've taken out about 90 to 97% of their previous range. What have we put in instead? Can you think of creatures we put in their place that we have to protect? Yeah, the domestic sheep and the cattle. We took out the yellow-legged frogs and the boreal toad with chytrid disease, bullfrogs, and more than a dozen non-native fishes. And of course our own native fishes, the Colorado greenback and the bull trout, are now slowly disappearing. We have diddled with the landscape. Is it an even trade? One for the other? Are they functional equivalents? They're not even close. So now I'll tell you a little bit about invasive species and climate research and how this may guide conservation. Well, as I was doing those acid rain studies and hiking through earlier in my career in Sequoia Park, I realized acid rain was a national priority. What wasn't a national priority was the alien grasses, the most altered ecosystem in the park. We weren't paying any attention to it. It looked like too hard of a problem. So it was put on the lower priority list. We studied backcountry campsites, which I had a great time doing, but it only covered a very small proportion of the park, less than 1%. Less than 1/100th of 1% of that park as campsites. It wasn't really affecting a lot of native species, except for the fish that we'd put back there. And those were the unfunded studies, the grassland fire studies and the fish studies, where we plopped those guys. Unfunded, low priority. That bothered me. So when I got to Colorado, the first thing I tried to do was load up carloads of students and start looking at the way we assessed native and non-native plant diversity, native and alien or exotic plants. And I learned that we were sampling them in a very funny way. We were using little tiny plots for 50 years, or little points along a line, with a high degree of spatial autocorrelation, one plot right after another. This is a silly way to do business. It was silly for 50 years. You went out there and you missed half of the native species and half of the exotic species at every site. So, I wrote a textbook. It's here, and this is the door prize. Now, the door prize goes to the student who is sitting furthest from the speaker. Sitting furthest. That's that guy in the green shirt. Come up. You get your door prize. The reason for that is I always felt I was crashing a party when I went to one of these science events. Okay. We had a good time, and while we were out there measuring things, we learned that the places that were highest in native species were also highest in exotic species. That meant our species-rich areas were being invaded. That's not good if you're a national park. It's not good if you're a state park or a reserve, or even in your backyard where you fertilize. This is a place that really affects all of us. Our hot spots for native diversity were being invaded. And you couldn't tell that if you looked at the small plots. You could get either answer, but if you looked in the big plots, you got the same answer almost every time. And what was fun was telling David Tillman, the most cited ecologist of our time, that he might have been wrong. He studied in 1 meter squared plots, and he sort of missed the story. He was telling everybody the opposite. If you have high species diversity, there's no problem. There was a problem, a big problem, and this was it. So I told him, you can't trust those little tiny small scale measurements. If I gave each of you a carpenter's level, sent you out all over the world, and said measure the tarmac when you got off the plane, and you came back and we analyzed the data, what would we prove? The world was flat. We made a series of great small scale measurements, very accurate each one of them, but we got the wrong answer because that data doesn't scale up. So think about it in your studies. What am I taking and how does that information scale up? Well, and that brings us back to the national park. This is a postcard they sell in Grand Tetons. I love it. It says the valley floor takes on many colors during the spring and summer. Yeah, because of the musk thistle from Europe, the red brome from Europe, and the yellow sweet clover from Europe. But I don't go to my national parks to see Europe. When you lose your biological integrity, you lose a little of your cultural integrity. And that's what we're losing as a society. It's trade and transportation. This is the graph. The graph kind of shows a conveyor belt of species moving from one country to another, mostly in the north. But there it is. That conveyor belt is bringing new species here all the time. Every 20 days, Hawaii gets a new species. Scary thought. We might get them more frequently with the increased trade right here. So some friends and I decided, and I call this graph the Friendswood Data Graph, friends from around the world got together and we said, hey, out of your 120 most frequently observed species, the ones that are out there on the landscape the most, what percentage of those in each of your countries comes from another country? Here was the answer. About half of our species on our top most frequent species list come from another country. Only 1% do in Europe. It's not nearly as invaded as we are. Curious. But in the southern hemisphere, where they're starting to pick up trade and transportation, what's happening? They're gaining in numbers and they're going to get more. Our sample size has always been small, way too small. This is a 15% sample of my favorite painting. Can you guess what it is? We'd kill to have a 15% sample. We sometimes have a less than 1% sample. But this is it. This is actually Madame Monet and her son by Claude Monet. I think they dressed their son funny, but the story is the same. We have to learn how to extrapolate our data from small scales to the bigger scale. We can't get by with just our tiny little samples. We have to learn how to extrapolate. That takes guts, and that takes modeling. So our group over the last 10 years has been working on spatial models, how to improve them, what to think about. When you collect data in the field, it goes on to a little recorder now. We load it up on the web, and we turn those dots, those locations of species we found or abundance measures, into a predictive map. Now this is kind of important because if you pick some spots that you didn't sample that turned up red like the species should be there, suitable habitat, you can go out and search those and save time and money. You can improve your odds of doing conservation well by using maps and models with a whole suite of predictor layers. Our first models weren't perfect, but they did show some alarming trends. And this one was of the white pine blister rust, a disease that came over to the United States around 1910. It spread rapidly down to California. CCC groups, government crews were yanking it out, ribes plants, gooseberries out of the ground in the 1930s and 40s. It was silly. It still spread, and it got into Yellowstone, and it got into Glacier, and it started whacking the 5-needle pines, really putting them out of business. About 90% mortality in some cases. But they can use these maps to go into those red areas and find survivors. Those survivors turn out to be pretty darn important genetically. Those are the ones you want to have planting programs with to help save the species. We learned in predicting rock snot, this is Didymosphena geminata diatom, lovingly called rock snot. It covers streams in a dark brown like toilet paper layer. The big fish leave, the small fish stay. Fishermen hate this stuff. But we found out that using different models, some models just perform very poorly. So you have to pick the right ones, work with the right people to come up with a good solution. With the snakes, it wasn't an elegant model. Here's the snakes in Florida now, way down there. All we said was, if you have a pet, don't set it free in the green zone. It might live. There's nothing that's going to stop it from living if you set it free there, back to nature. Don't let it go. Give it to North Dakota, somewhere up in the blue area. No, don't do that. We tested the models on rare trees and rare species. And the rare trees in New Caledonia, we only had 11 trees that they found for this species. So we asked, where's the 12th one? And they went out to those red areas, saving time and money, and they found a 12th individual. Good news. In mapping the Yosemite toad, we found that some populations are quite happy, but other populations of the toad are sent out all over the wilderness to find new areas, new habitat. That's their job. But if they're too close to harvested areas or previous fires, those populations collapse. So we learned how to manage those toads a little better with some of these models. We did some of the first modeling of the Asian carp, up to 6 feet long, will knock you out of a boat, and is now heading to the Great Lakes and could cause a collapse of a $1 billion a year fishery. The first models we did, even with, they had less than 17 points, said, hey, the Great Lakes look like they might be in danger. It's kind of fun. I modeled a human invader. That's us. This paper got rejected 4 times, I'm happy to report. I compared us to fire ants in the abstract. They didn't like that. Little bulldozers. They didn't like that. So I kept changing our little title, but still, we really do a number on a landscape. We pave the heck out of a place, and then we bring in invasive plants to cover our lands. It's not a good thing, and we're spreading in very predictable areas. We can predict our behavior 92% of the time. We like good number of growing degree days, high humidity, low slopes, and just the right elevations. Dun, 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 dun. The good life. The same as the exotic plants liked and the exotic birds, we all seem to gravitate to these nice areas. So, and now we're experimenting with ensemble models where we group whole bunches of models together and see where they agree, because we won't put all of our faith in one model. Let's try an ensemble approach. And when we tried this in Yellowstone National Park for Dalmatian toadflax, we found out that, yeah, the ensemble model worked better than any individual model by itself. So we're learning a bit about how to model in space. But now I thought I'd take a glimpse into the future, because it's not enough to use hindsight, and it's not enough to model in space. It's going to take real courage to do ecological forecasting. Ecological forecasting. Think about it. Multiple drivers, ecological forecasting. I can do that job. No, it's going to be hard. So here's where I pay homage to climate scientists. They had the guts to model 100 years in the future. They might be wrong, but they had the guts to do it. And we need to have the guts to do it in biology and in ecology. Maybe not 100 years if we're real sissies. We could stick to 10, 20, and 30. But we've got to start projecting. We have to start using scenarios. And we have to start thinking about the scenarios of what if we're wrong, the consequences. What if we're wrong? So we did this, and we added some future layers to some of our maps, cautiously. But now, instead of looking at just the probability and uncertainty in space, we have the problem of the probability and uncertainty in space and time. Now, we have textbooks on time series analyses, and we have textbooks on spatial analyses, but we don't have textbooks on spatial and temporal analyses. It's really hard work. We're going to make a lot of errors. I think it's going to be exciting. We started off with a small test. There's Cindy Brown right here, and one of her students, Jim Bromberg, had come into my office and said, you have data on where cheatgrass was in 1999 and 1996 and 1999. I want to borrow it. Okay. And so he went out and collected some more data, and all he wanted to show was that if you had a model in 1999, it would predict what went 1996, the first year, you could predict what's going to happen in 1999. And if you knew what was going to happen in 1996 and 1999, you could do a pretty good model of what's going to happen in 2007. That gave us some confidence that over short periods of time, we might be able to not quite predict the future, but at least put bounds around it. And in a manager's lifetime, they're not going to be around 100 years from now. We can rub Jim's nose in this if he's wrong. I think he works. He works for the park right now, so we could rub his nose in it right now if he's wrong. But then down here's an area, Wild Basin at the very bottom, and it kept getting redder and redder and redder. So the habitat was improving for the grass, for cheatgrass, along the same time we were doing our modeling. So we sent out crews to Wild Basin and we found cheatgrass. These things might actually help conservation biologists. But climate change won't be easy. Here's kudzu eating a baby. Oh, I was going to be an alarmist today, but in fact, I got in trouble for showing this once, and I probably shouldn't have shown it here. It was wrong. The bottom line was our models showed that most of the areas of kudzu are very stable, but look around the edges, focus around the edges, and sure enough, some of the latest samplings and findings of kudzu are in Connecticut, New York, and even in Canada. We started playing Paul Evangelista with models of not just mountain pine beetle, but 6 species of forest insects. We said, well, what's going to happen to them with climate change? 3 improved with climate change, and 3 did not improve with climate change. Huh. Normally, we thought climate change would make everything worse. Not so. But these models were oversimplified. They didn't include land use. And there's climate change over that same mountain close to the Fraser Experimental Forest, and the red hand of death. It's really great. But note that the beetles in the same climate change did not get the 40 and 50-year-old forests. What? There's an interaction between land use and climate? We got to consider that. I saw so many newspaper articles about the effects of climate on bark beetles. Not one time did they mention a potential interaction with land use. They were giving you half the story. We know that we have a lot of work to do, and in the kudzu model, luckily we have Catherine Jarnovich. Is Catherine here today, or did she skip out? She's gone. We call her Catherine the Great. She takes on really hard topics, and in this case, it's climate change and uncertainty in space and time. So we can develop a map with error bars down here. We can tell you where there's new novel climates. Don't go modeling in that area. Stay out, stay out. We don't know enough. But now we can look at variation in space and time. We're just learning how to do this. Now they'll pay us to look at climate change, invasive and invasion. We can get money for this kind of research. So this is the model of African fountain grass, a very dreadful African grass species which grows really tall and can carry big fires. And so they'll pay us to do the current distribution map and the future distribution map. What's wrong with this map? Oh yeah, they sell it in Grand Rapids, Michigan. It's going to be all over the place and a lot sooner than 2040. Don't you get it? Climate change may change habitat 5 kilometers a year, something like that. But a Walmart truck or a Home Depot or some big group like that can move species at 500 kilometers a day. We can get money to study climate change, but we cannot get money really to study commerce. That's the direction we need to know. We need to go there and we need to start predicting where things are going and how fast they're going to get there, because they're screaming in trucks and cars and boats and planes. They're crawling with climate change. So I thought it'd be fun. With a group of Park Service scientists, we just started messing up, we started looking into an older paper that was done about alien species in national parks, drawing a line in the sand. I love this concept. This is what they wanted to do. They said, here's what we are. It's 1995, it's conservation biology. This is our #1 issue. It was quickly ignored by the scientists out there, cited only 11 times. So I thought it'd be fun to go back and see how well did we do since 1995. Well, they talked about Haleakala National Park in Hawaii, and they found out that, yeah, they had eucalyptus trees, and they had wild hogs and wild goats and axis deer, and they put a fence around the park, a cyclone fence, 34 miles of fence. And they kept out the wild hogs, the goats, and the axis deer. They did a great job. 17 years later, unfortunately, other things came in right through the fence. Little seeds flew right over. And now they have all kinds of very harmful trees that are going to take over. I mean, absolutely take over parts of that island. Myconia is one of them. It took over Tahiti. A third of Tahiti is covered in Myconia. It covers a giant, creates a giant dark canopy where, I mean, it's a biological desert underneath it. And it's in Haleakala. And since that time, the honey creepers have almost all gone extinct. We have a few, and some of them are lingering, very rare, but from avian diseases, from malaria, carried by alien mosquitoes. While we were building our fences, things were crossing, small things. In the Grand Canyon, they had a burrow problem. Well, they fixed the burrow problem, and they started a very good program of inventory and monitoring. And they've pulled out over 600,000 individual non-native plants, and that's good. Over 290,000 tamarisk trees have been removed, and that's good. But since that time, New Zealand mud snail has come in. They still have 13 species of alien fish having very negative effects. They have a dozen new plant species added to their invasion list since that time. And they have a herd of bison moving in from the Kaibab Plateau. They didn't ask for them, but they're moving in. People love seeing them. Uh-oh. In Olympic National Park, they have these beautiful goats. How many of you have seen these goats in California, thanks to the Fish and Game? Anyway, yeah, they're from Canada. They look nice. But they gored a guy and left him in Olympic. He died pretty soon afterwards. So Houston and Schreiner in that article mentioned the goats specifically, so we thought we'd check. And sure enough, they still have the goats. There's a lawsuit pending. They can't get rid of the goats till the lawsuit is over. And they have trouble anyway. And since then, the barred owl has started taking over, another native species is taking over the habitats for the northern spotted owl. Mostly they think because of the land use changes around Olympic National Park, not inside. They extirpated the wolf years ago, the coyotes have moved in, and now the coyotes are going after Olympic marmots, a rare marmot. The wolf didn't go after the marmot, the coyotes did. That means there are cascading effects when we make a management decision, like, oh, let's extirpate wolves, let's not put them back. Something else may pay the price for our decisions. And the deer are losing their hair. That's right, they have a hair loss syndrome caused by deer lice. I don't know how important that was, but I thought you should know. What's happened in Everglades? They followed small mammals on the sides of roads, and the small mammals have disappeared. Not in 2100, not in 2030, just in the last 10 years, very rapidly. The rabbits are just about gone. They can't find any. Find a few raccoons, very small and scared, possums and bobcats. They've even taken deer. These pythons, as you see that one being held up there, they eat big. They just found a 17.5-foot python with 87 eggs in it. Do you think that population is going to explode? If you think 30,000 pythons in the Everglades is bad, Wait till there's 300,000 in South Florida. And they're small but dangerous creatures flying under the radar all the time. The Africanized bees, the white-nosed bat syndrome, the plant diseases which somehow sneak through the cracks and across our fences and across our borders. There are more small things, mosquitoes coming in weekly or monthly or yearly, but we're not paying enough attention. And there will be prices to pay. But I have hope. Even as down as that sounded, why do I have hope? Because the next generation of scientists are just a heck of a lot smarter than we are. And I'm pretty proud to say that some of them, like Nick Young. Nick, are you here? Raise your hand, Nick. Oh, there he is. There he is. Nick thinks outside the box. So in helping the NEON develop sampling protocols, National Ecological Observatory Network, Nick found out that by sampling an area bigger than you need to, you can improve your models inside the box. Thinking outside the box was important. And now he's taking those same skills to work on mountain Nyala and a couple other creatures in Ethiopia. We have Paul Evangelista, who's taken what he's learned from the western pine beetles, and he's used the same similar models to look at food security in Ethiopia. Where's the corn going to move in short term with climate change? These are important questions to ask. I like this. Moving to think of people in the business of conservation helping others. This is nice. One of my students is a crow student up in the Crow Reservation, Valerie Pretty Paint Small. And she's looking, they're having problems doing a ceremony, the Sundance ceremony. It was outlawed years ago, but they still perform the Sundance ceremony twice a year. And it's a little scary. But they need a large cottonwood and they need lots of small cottonwoods. But Russian olive has invaded, and now they can't find enough small cottonwoods or the right size large cottonwoods for their some ceremonies. They have to go really far away. Unfortunately, the ceremony demands that you carry the large cottonwood back to the site. So now we're moving our biological modeling to help cultural resources, and I think that's pretty cool. We have Dave Barnett, who's thinking about triage at local scales. If you have 2 invasive grasses in a refuge in Hawaii, which one do you go after right now? You only have money for one. Well, if it's kukua grass and velvet grass, he ran the models and it showed that kukua grass was moving out of the system in time, but velvet grass is moving into the system. If you only have this much money, go for the one that's moving into the system. Another very valid use of climate models to help in that triage and decision-making process. We have Tracy Holcomb, who I know who's here. There's Tracy right there, who looked at risk for a dozen or so top plant invaders in the US. Now what was clever about this was we didn't know what the answer was going to be, and Tracy came back, she goes, well geez, half of the species I looked at were helped by climate change, and the other half I looked at looked like they're going to get hurt by climate change. Another recent report from Australia says most of their invasive grasses could be hurt by climate change and increased drought. We can't assume that climate change is going to make everything worse. It might help us solve a few of the problems if it goes in the right direction. And then we have Catherine the Great. Almost everybody wants to have Catherine on part of the team because she's a real geek. And I mean that in the nicest way, but tape in the glasses, she really understands the ins and outs of these models. Not to rely on the defaults, but to look at each and every careful choice that you make in running the models. How to look at uncertainty in space and in time, the novel climates, and what the error bars mean on the map. And so when she did this work on the Africanized honeybee, she learned that she had to separate it out into 2 groups of honeybees to provide the best model, a mosaic of models. Really clever stuff. And then we have Sunil Kumar, another guy everybody wants on the proposal. Sunil, are you here? Taking the day off. Sarah, make a note of that. But he's pretty darn busy actually finishing up this white-nosed bat syndrome work. This is the old map. I couldn't show you the new map, 1, because it's not published yet, and 2, because it would scare you right out of the hall. It's moving at a very rapid rate, and when it gets into caves and the bats get it, boom. there's 90% mortality. It's the smallpox of bat diseases. And of course, he works on a number of other species as well and really understands the GIS and spatial aspects of a lot of our work. This is Jim Graham, and he's adding animations to the work, and this is the gray whale. And I want you to focus on the, oh, there it is, the Mediterranean, how it blinks on and off. The gray whale isn't found over there very routinely. In fact, it hasn't been seen in the Mediterranean in 200 years. And yet this model said, hey, that's pretty good habitat. And there it was in 2010, a gray whale in the Mediterranean. So I think these models are going to be useful if we stop hunting them into near extinction and letting them go where they want to go. They'll go to some pretty fun places, and we'll all get to enjoy them. And there's Sarah Simonson, who's looking at invaders across barriers. Our weeds are creeping up slope, and avalanches coming down slope create great habitat for the invasive species moving up slope. So it's nice to know that we're fencing in, we're putting our borders around where the invasive species are going to go. So it's really good work by Sarah. And one of my favorites is Greg Newman, who's worked for me the longest, I think almost 18 years. And Greg, are you here? There he is. And Greg did something absolutely spectacular. He reached out to citizen scientists. So he's creating an avenue for us to share work and for others to give us important data with their own work, training them and using citizens to help science along. And there will be lots of citizens who would love to help with conservation triage. So now, very quickly, my prescription for the future, only 4 minutes, and then time for questions. So here's my prescription, and I don't expect you to believe me, don't listen to me. So I'm just putting this up there. If it were up to me, if I were in charge, I'd say focus on the proximate threats to rare native species. Don't do anything else for a while. Those are our emergency cases. Contain the species, alien species in Hawaii. It's really bad news there. We've got to have a much bigger portion of our work there. We have to contain alien apex predators, the Burmese python, other snakes, the Nile monitor lizard, and alien fishes where they shouldn't be, the lake trout in Yellowstone. These guys are big eaters. We can't afford to have alien big eaters. We want to restore native predators. I think this is very important for those cascading effects that we're still not thinking about too clearly. We want to prevent epidemics of zoonotic diseases. I worry about mosquitoes and new species of mosquitoes that are coming in. Chet Moore's right there. Chet, raise your hand. Chet knows everything about mosquitoes. We're worried that all of a sudden dengue fever is going to be something we have to worry about 6 months of the runs. Believe me, I'm not looking forward to it. We want to contain, we want to restore natural processes, flow regimes where we can, fire regimes, and migration patterns. We want to contain alien plant pathogens. I'd put them on the list too. They're going to be really hard, so they're lower on the list. We want to remove alien game species and actually force the people that put them there to do the removing. We want to contain alien plants. They're on the list too, but they're further down on the list. I just don't see them pushing things into extinction that quickly. And then we want to plan for climate change and other stresses alongside some of these other things that we're doing. And we actually need to do the climate change research to help some of these other facets. So I think it's all kind of important. But if you did it my way, we'd be doing conservation triage the old-fashioned way. We all have our heads in the sand. One person making a decision. And there's me, the invasion scientist, the physical scientist. We all have our own views of what this conservation triage should look like. This is the wrong model. This is not right. This will not advance the science. This is what we've been doing for 100 years. This is wrong. The right way to do triage is to bring in local stakeholders, scientists and managers, have a bunch of data and some scenarios, and try to quantify the consequences of making the wrong decisions with our models. Develop a consensus model for which species and which habitats are going to go higher up on the list as a consensus of experts and managers and funders, and maybe even corporations. And to do this in an iterative way, to do monitoring so that you can find out if you're wrong and adjust, or you can take pride in if you're a little bit right. I like the model that the NC's had in Santa Barbara, that the Powell Center has right here in Colorado, and that different conservation, landscape conservation groups have throughout the U.S. I like this idea of consensus building for conservation triage. In the end, we're going to have to spend a lot more money on prevention because basically all our continents are together again. Our customs agents are not keeping out everything. Somehow we sneak in 2 shiploads of drugs here without being seen. Things happen. They get through. Eventually we're going to get a super species and it's going to hurt us. We're going to have to rely a whole lot more on forecasting and scenarios and figuring out what the consequences of being right are and the consequences, more importantly, of being wrong. And we're going to have to continue monitoring, and monitoring not just the things we do in the field and be happy with it, but how things are getting to your field. So we're going to have to incorporate commerce. In the end, triage and conservation will get us back to the basics. We need wise use of natural resources, we need to protect native species, and we need to leave the world a better place for future generations. And the next generation of scientists, these are our NASA fellows and Colorado View folks, there with the hard hats on, they have the hard work to do. I'd like to acknowledge the graduate degree program in ecology and the students for this great honor, my co-authors, grad students, and research team who deserve all of the credit, the Department of Interior, National Park Service, National Biological Survey, and USGS who foolishly funded me for 34 years, my heroes in life are Don Quixote from Miguel Cervantes, many leaders in fictional novels, Aldo Leopold, Rachel Carson, the next generation of scientists, and Malala Yousafzai, the 14-year-old Pakistani girl who is almost losing her life because all she wanted was an education to become a doctor. I want to thank my lovely bride, family, and friends for coming today. That was quite a treat. Thank you very much. Do you have any answers? Any answers out there? Oh, questions, questions. That's what I meant, questions. Yes. Oh, Phil.
So the triage metaphor comes from war, right? And you've been talking about triage. Do you have anything to say about stopping the war on nature, which is causing all these problems? Or anything to say about the insufficiency of triage in the absence?
Yeah, I'm not a big war fan. I don't like that terminology very much. I think it's a very loaded term. I do think for the last 100 years, we are seeing a slowdown in direct land use conversion here, but we're not seeing that slow down in developing countries. We're seeing population increase, not so much here, but in developing countries. But where are we doing all the work? Here. I think really what we need to do is do what Paul Evangelista and his group has done, is to carry our work to other parts of the country. Is that we're not getting that message out. I mean, there aren't big believers that conservation is the best use of our time and money. And I think it's very important. Well, that was easy. Apparently you all got blue tickets. Oh, yeah. Jeff.
So with the daughter in medical school,
yes, daughter in medical school.
Triage kind of analogy.
Triage.
I've been wondering, I'd be interested to hear your comments about, it seems like the medical profession, especially pharmaceuticals, do a little bit better job of connecting the research to address a specific problem, implement that problem and solve it.
They do.
So the disconnect between ecological science and problems in ecology or nature, can you attribute that to some gap that we could fill, or is there anything to learn from other science?
Yeah, I think there is. I like the idea of getting local groups, like maybe around your national parks or counties, and start having these, just talk it out. What are your big topics? What are the things that we know about as a group of scientists and colleagues together? I think our lists are way off. If you go on the Google website right now and you look at science, 8 out of those 10 articles will be about outer space. We're not getting the message across that the earth is important to us. Here's where the curiosity is. And in local areas, we're not getting the message out that we care about your specific problems. We're sort of, we go with the national priorities sort of approach. They told us this was important, the acid rain studies, so we're going to do it in your national park. We didn't start from the bottom up, and I like starting from the bottom up now. I've come around. Yes?
So I was at the Eco Summit meeting in Columbus, Ohio a couple of weeks ago, one of the ESA and site restoration. One of the big ideas there was looking at ecosystems not simply from the standpoint of restoration, but looking at novel ecosystems that even though they may have invaders, may still be able to provide vital ecosystem services, ecosystem functions, in spite of the fact they have no resemblance to a historic condition. Could you comment on that as a conservation?
How do I feel about novel ecosystems? So an invasive species comes in and takes over like the grasses in Sequoia Park. Let's just be happy with it. Let's call it a novel ecosystem, and maybe we can move on to the next one.
As a form of triage.
As a form of triage, yeah. And I'd say we would have made a big mistake had we not tried burning even in that novel system. What we found out by burning the native grass, the non-native grasses was, it came back 4 years later. And at first, my boss writing up the paper said our work was a complete failure. Then we looked at the data more closely and we found out that in that 4-year period, native species were able to come up and set seed and maybe preserve the species by saving the viability of that seed for a little while longer. That no, I'm not throwing in the white flag. No. I don't like novel ecosystems. I'm sorry. Not going to go there.
Novel books, not novel.
Yeah, that's right. Yeah, novel books. Just an opinion. I'm probably wrong. Dave.
Because I understand the triage process, though, there is
Yeah.
one group
You're going to die.
that
Yeah.
lost cause.
Right.
And do you factor that into your
I have factored that in. And so when I look at bringing back the mastodon, I put that in one of those. There's not going to be, I don't care how loud the Save the Mastodon group talks, I'm not sure we're ready to bring that baby back. The wolf? Everything else, the wolf I want back. Grizzly bear I want back. I feel cheated. All right, let's go enjoy those blue tickets. Oh. Shucks.
That lady hasn't sung.
So, those of you who have been here a long time know that Tom used to be a host for Distinguished Ecologist series, and there was a tradition whenever there was a speaker, and so we now will want to treat Tom with that tradition. That is that, you may not know it, but today is Tom's birthday.
Oh, God.
And so, we actually
It does come back to haunt you.
we actually have some gifts for him. You see, it's wrapped in birthday paper.
Oh,
This
gosh.
is, first of all, from your colleagues
My colleagues.
here in GDPE, and you have to
Uh-huh.
open this first
I'm just,
and let us know.
I'm just
Read the
stunned.
little sticky note on
Yes,
the
I
front.
did this to very famous ecologists for many years. Then I'd take them out and get them a little whooped at Trace Margaritas. The Style Guy GQ magazine.
And the note says,
And the note says, here's to help you clean up your act. Your GDPE colleagues. I didn't get the memo on the dress code.
so then actually we have another gift which came from one of your best friends. Yeah, don't lose that.
Okay.
Style guy.
Yeah. Not gonna
About
lose-
a country sent this for you, hearing that you were going to be honored in such a way. And there's a little note on the front, and we'd like you to read that
No
note
kidding.
and open the book. Yeah. Open the book.
Here's a book I thought you would certainly want to read and keep by your bedside. Your best friend, David Tillman. Hey, you can't make an omelet without breaking a few eggs. We disagreed at one point. We did co-author a paper together, though. Don't get me wrong. We did that. I hope.
And the book is?
The Functional Consequences of Biodiversity. David Tillman.
So we're going to have a book signing.
Oh, God.
Usually there's the author signs books, but in this case what we'd like is all of you,
Oh,
or any
my
of you
gosh.
who would like to, would please sign this as a memento.
Oh, God.
for today.
It just gets more embarrassing.
And so here, of course, is the real honor for Tom, and it's 2012 GDPE resident ecologist, Tom Stohlgren.
Thank you very much. Thanks again. Thank you. Thank you all.
Thanks a lot. Tell them what Jonathan Straubing said to you about this. Go ahead.
No. That's
Jonathan said, you know what this means if you've been selected for this? Tom said, no.
Yeah.
Jonathan says, they got down to the essence.
They got down to the essence. He tried to hurt my feelings. Jim sent me an email. Kurt sent out an email saying, in 26 hours, Stohlgren's going to speak. Jim writes an email quickly back to me that says, if there's a God, it'll be over in 27 hours. I get a lot of abuse. Thank you very much.